Let me get it up here. All right, this entire lesson is going to be about average rate of change, which is another word for slope, especially when we're talking about word problems. And because there's a lot of writing on this, at least on the front page, I'm going to be using the pen instead of the tablet because my handwriting on the tablet, as you know, is not great. So if you hear a lot of tapping, that's why, because I'm using the pen. Okay, a couple of things. So average rate of change or rate of change is what we call slope when we're working word problems. And there's a very specific way to figure out what the rate of change is. So before we get into that, we've got to review a little bit of vocabulary. First of all, we have right up here, let's activate the pen because I am going to be using it. All right, we've got an independent variable. Independent variable is the same thing as input, which is x normally, and that's also where we find the domain. The independent variable is the variable that causes change. Okay, the dependent variable is usually y, and it is the output and the range. And it is the variable that reacts. It doesn't do anything unless the independent variable does something first. All right, so breaking this down, and these are kind of rough definitions, but by the end of the lesson, this will be clearer. The rate of change is a ratio of change in output units to the change in input units. The part of this to remember most is this little delta symbol means the word change. So this says change in y over change in x. And the really important part to remember is that y is always on top. Let's see if it'll let me write with this. And apparently it's not going to. So we might be writing with the tablet anyway. Let's see why not. Okay. Nope, not going to let me do it. So we're going to use the tablet anyway. Okay, give me a second to switch over. All right, right here. Okay, it is always y on top. And that is actually the most important part to remember. Whenever we write this, you've got to remember to put the y's on top. All right, so the average rate of change is a calculation. And you've seen this formula before. This formula is for finding the slope. And it says the change in the output values divided by the change in the input values. So in order to use this formula, all I need is 2 points. And we're going to do that today. All right, so we have the unit rate, the average rate of change, and last week, the rate of change, the average rate of change, and now we've got the unit rate. Okay, the unit rate is the number of output units per a single input unit. And again, this is all going to become clear later on. So let's erase this. And let's go ahead and scroll down and let's get into examples. All right, so this is the first part of the practice is going to be just like this, and then the set of examples I do next will be just like the rest of the practice. For each situation, define an independent and a dependent variable, then find the rate of change, determine if the slope is increasing, decreasing, or flat. Okay, so I'm looking for an independent and a dependent variable. The total cost, including shipping, for ordering 5 uniforms is $66. The total cost, including shipping, for ordering 9 uniforms is $114. All right, what I have here is I've got cost and I've got uniforms. One of those is independent, one is dependent. Now, I'm going to say that I wouldn't have shipping costs unless I had uniforms. So therefore, my independent variable is going to be uniforms. I've got to have uniforms first before I can worry about, did it change color? Nope, still red. finally do it? Yes, there we go. Okay, so uniforms is going to be independent. It's going to be X. And my shipping cost, or just cost in this case, is going to be dependent. That makes it Y. So down here, this is uniforms. And this is going to be shipping costs. And since we already know that we're dealing with dollars, we're going to make sure we attach units to this. Sometimes the costs don't say what they're in, but in this case it says the cost is in dollars. So I'm going to put a dollar sign so that I know that that's the units for my dependent variable. All right, now in order to use the formula for finding slope, I have to have 2 points. So let's go and see if we can find enough information up here to get 2 points. I've got 5 uniforms at $66, and I've got 9 uniforms at $114. So if uniforms are X, then I've got one of my points is 5, and here's the Y that goes with 5 uniforms at 66. And my other point then is going to be 9 uniforms for $114. Now I've got 2 points. I can find my slope or my rate of change, which are the same thing. Okay, and I find that by plugging those into the formula. So I know that M is going to be equal to, and it's Y's over X's. So 114 minus 66 divided by 9 minus 5. And that's going to come out to, and I don't really want to, let's see, go through a lot of fractions, so I'm going to run that through my calculator, which will automatically reduce that. And that gives me 12 over 1. Okay, so we have Y's over X's. So what does that mean over here? This is a Y. Y was cost in dollars. Okay, so that tells me my rate of change is $12 per, what was down here? Uniform. This was uniform, which was independent, and its X's on the bottom. And this is cost up here in dollars. So when I write out what my rate of change is right here, my rate of change is $12 for every uniform, or per uniform. We're going to see how we can interchange those words later. All right, now tell me what's going on here. My slope is positive. My rate of change is positive. So am I increasing, decreasing, or flat? My slope was positive, so that tells me that I'm increasing. And what that means is that every time I add a uniform, it's going to increase my shipping costs by how much? $12. Okay, next example. The length of a bus route is 4 miles on the 6th day and 4 miles on the 17th day. All right, now, here is something to remember. This is a tip, and you might have heard this in another lesson. Anytime I'm dealing with time, time is almost always independent. So the time that I'm working with here, I've got days, and days are a measure of time. Hours, minutes, months, years, all of those things are measures of time. So that tells me that day is going to be independent, and it's going to be X. So days is here. And what else am I measuring, or what else is happening here? The bus route is 4 miles on the 6th day, and it's 4 miles on the 7th day. So my Y here is going to be miles. That's what's going. Every time the day changes, then the miles are going to change. Although we're going to see in a minute that this is sort of interesting. All right, so trying to fit in the points over here. Remember, I need 2 points, just like I had up here. This time I'm going to put them over here. I've got 4 miles on the 6th day. Day is independent, so it's x. So I've got a 6, comma, 4 as one of my points. And on this side, I have a 17th day. So this one is 17, comma, 4. And you might already notice there's something a little odd going on here. And to plug those into my exact same formula, m is going to be equal to, it's y's over x's. My y's are both 4's. So I've got 4 minus 4 over 17 minus 6. And that's going to give me a 0 over an 11. Okay, any 0 divided by anything is going to be equal to 0. Okay, well, that's not a positive slope. It's not a negative slope. So it can't be increasing or decreasing. And if I look at what's going on here, it's flat. Because on the 6th day I drove 4 miles. On the 17th day I drove 4 miles. How many miles do you think I'm going to drive on the 25th day? Still 4. So my slope is flat. And if I were to graph this, anything that has a slope of 0 is in fact a flat horizontal line. So it doesn't increase, it doesn't increase, it just stays flat. All right, so how do I read this? Okay, this would be, let's see, 0 miles for any day. There's 0 change per day. And the wording on this isn't going to be really specific. The point is that there's no change in increasing or decreasing. Okay, so I'm writing pretty slow. I'm assuming you can keep up with this, so I'm going to go ahead and erase this. If not, then pause the video. And I'm going to go ahead and scroll. Okay, one more example, and then we're going to get down to this box at the bottom. Okay, so we're still looking for a rate of change given the information in the problem. And this time, we still need to figure out independent and dependent variable. A student earns a 98 on a test for answering 1 question incorrectly, and earns a 90 for answering 5 questions incorrectly. Okay, so I've got a score here, and I've got questions. So do you think I get the score based on how many questions are incorrect, or do I get the questions incorrect based on the score? I am pretty confident that independent here is going to be the number of incorrect questions. That's the only thing that makes sense. So, incorrect questions, not correct questions, we need the entire things. That's going to be X. That determines what the score is. And because we're talking about the count of how many, I'm going to say the number of incorrect questions. If I can fit that here. And it looks like I'm going to be able to. Okay, that's independent. So dependent up here is going to be my test score. And it doesn't actually use the word score, but that's what we're talking about. So I'm going to say test score. Okay, now again, I've got to find 2 points to make this work. I've got a 98 with a 1, and I've got a 90 with a 5. Remember, it's going to be, we have to, questions is X. So I'm putting these over here. And if I miss one question, I get a 98. And if I miss 5 questions, I get a 90. Okay, so I'm going to use my formula for slope with my 2 points, because I can always find the rate of change if I've got 2 points. So I've got a 90 minus a 98, and I've got a 5 minus a 1. And that is going to give me a negative 8 over 4. Okay, reducing that's going to give me a negative 2. Okay, that's definitely a negative slope. So the slope is decreasing. And why is it decreasing? Because every time I miss a question, my score goes down by 2 points. So how would I describe this slope? I think I would say that my score decreases 2 points for every missed questions. Don't worry about specific wording on this. It's more important that you understand what the number is here and what's actually going on in the situation. 2 points per missed question. All right, now here's the box down here that holds all the wisdom for the lesson. So I'm actually going to change the color if it will let me. Let's see if it will let me go to a red pen. But it did. All right, slope and unit rate. The rate of change is a ratio. It's the change in y over the change in x. We're going to learn how to read this and then write it out this way as a ratio. Ratios are fractions. We're going to write it with the correct units, and we're going to use one of these words in between it. And we've already used the word per. Right here I used the word per. I used the word per up on the first example. These words can appear in the word problems, and they all mean the same thing. Per, each, and every. It means if I change one here, it's going to result in a change per unit up here. And unit rate says that whatever it is on the x units on the bottom, if it's a unit rate, then the bottom unit is going to be 1, a single value of the units. So let's walk through something before this gets too confusing. Let's say that I'm going to drive home this afternoon, and I'm going to go 60 miles per hour. That's my rate. You know that? It's a rate you've seen every day since you were probably 9 years old or so when you started recognizing what it meant. So let's walk backwards then. All right, 60 miles is going to be y. So up here, this would be 60 miles under here. Per hour says I've got 1 hour. And I've used the word per. So 60 miles per 1 hour is the rate of change. And the unit rate, since that's a 1 down here, is going to be the same. It's 60 miles per hour. So that's already 1 unit. So that's why that would be a unit rate. Okay, we're also going to go into the next set and we're going to have initial values. Okay, the initial value is the y-intercept. And y-intercepts all have x values of 0. And this value is where it crosses the y-axis. And when I describe an initial value in a word problem, it is a y value. This is a y. So when I describe it, I'm going to use the units for y. So over here, If I had an initial value for this, it would be in miles because that's what my y units are, in miles. Okay, so we've got 3 more examples. Let's take a look at those. Yeah, let's click this and scroll. Okay. The number of grapes, let's get the pen active again. The number of grapes, G, depends on the number of branches, B, off the main line, and is modeled by the equation G is equal to 100B plus 4. So we got a whole ton of information. We don't even have to guess. It says that grapes depend on branches. That makes sense. I can't have grapes if I don't have branches to begin with. So grapes are going to be dependent, they're going to be Y, on branches, which will be X. So my independent variable is going to be branches. And my dependent variable is going to be grapes, specifically how many grapes there are, but I'm not going to get too fancy yet. All right, so what is my initial value? Well, I've got a 4 right there. We said that that's the y-intercept. So as a y-intercept, it looks like this. And that means that that 4 is a y value. So what describes that y value? That's grapes. So my initial value is 4 grapes. Okay, let's find the rate of change up here. I've got, let's see. I've got, trying to think what I've got. I've got 100, that's what it says. Okay, this is my slope. And remember, it's y's over x's. So it says I've got 100 grapes for every 1 branch. That makes sense. That's reasonable. So my unit rate over here, I've already got this down to 1. I don't have to do anything to reduce this. Also, it's okay if you end up with decimals for unit rates. Unlike when you're graphing, when you need to keep this as a slope, as a fraction, when I'm getting into a word problem, this slope as a rate of change can be a decimal. But in this case, 100 divided by 1 is 100. So my unit rate is 100 grapes. And we've used per a lot. Let's go ahead and say for every branch, just to change things up. That should not be graper, that should be grapes. $100 grapes for every branch. So one more time. Y's always go on top, and our Y's were grapes. It's right here. Y's were grapes, Y's were grapes. X's always go on the bottom. Our X's were branches. Branches right there. So here's my 100 grapes. Where did I get the 100? Right there. 100 grapes over 1 branch that doesn't have an N in it. Can't spell either. And that gives me a unit rate, because I want this for 1 branch, which it already is, of 100 grapes for every branch. Let's go on to example 2. All right, this time we're going to look at a table. The last one we're going to look at a branch or a graph, so there's one of everything in this lesson. All right, first question says, is this a linear relationship? And how do we know? Let's take a look at it. Okay, we subtract backwards to see if it's linear. So let's go ahead and start subtracting backwards. So from here to here, I've got 48 minus 36.
And that is going to give me 12. And if I subtract backwards here, I've got 36 minus 30 is going to give me a 6. And one more time, I've got 30 minus 18, which is going to give me 12 again. So right now it doesn't look very linear because I don't have the same amount here. I don't have the same rate of change. But we're not going to decide that yet. We're going to do this side first. All right, so 8 minus 6 is going to give me 2. That's interesting. It's not a 1 this time. And 6 minus 5 is going to give me a 1. And 5 minus 3 is going to give me a 1. Or excuse me, a 2. So it looks like I actually, if 1 changes, it changes by 6. It looks like I just need to find the missing amount. So this would be 3, 4, 5, 6, 7, 8. So we need to divide these by 2 to get the right amount. So if I divide this by 2, that's going to give me a 1. And if I divide that one by 2, I've got to divide this one by 2. And there's the 6. So that one's okay. So let's divide this one by 2. That's going to give me a 1. And same thing here. If I divide this by 2, it's going to give me a 6. So I do know it's linear because my slope, or my rate of change, is 6 every time I have a change in 1 over on this side. Okay, now the problem is I've got a 3, 4, 5, 6, 7, 8. I know what that's going to be. I know what the problem is, but you're not there yet, so wait till you get there. All right, time washing cars in hours and the number of cars washed. We have a rate of change of 6. Let me put that. A little ahead, sorry. All right, we can't assume that this is X and this is Y, so let's look for more information. Remember, independent variable, if I've got time, it's probably going to be the independent variable. And my time washing cars is in hours, so here's my X. It's going to be number of hours. And if you want to put just hours for now, you'll be okay. But you're going to figure out that if you put number in front of it, it makes more sense. All right, cars washed then is going to be Y. So this is number of cars washed. What I don't have right now, because I don't have a value in this table for 0, is I can't find my initial value, which is a y-intercept. So we're going to have to find it in the table. We learned how to do that already. So let's take this table up. I need a value for 2 hours, a value for 1 hour, and initial value says 0. Okay, so if I do 18 minus 6, that's going to give me 12 cars after 2 hours. If I do 12 minus 6, it's going to say 6 cars after 1 hour. 6 minus 6 is going to give me 0 cars as my initial value. So here's my y-intercept. It's the origin. And that makes sense. If I hadn't had any time, then I wouldn't have washed any cars. So my initial value is 0. And remember that this is a y-intercept, so I want the description that goes with y's. And that's cars washed. So my initial value is 0 cars. My rate of change is going to be y's over x's. So I'm going to have 6, and the units for the y's is cars. And I've got hours on the bottom. So every 1 hour, I wash 6 cars. Makes my unit rate 6 cars per hour. Or each, or every. If you like the other words, you can use them. My equation, I need a slope, which is my rate of change, and I need a b value, which is the y-intercept, which is also the initial value. So my equation is going to be y is equal to, and there's my slope of 6. We're using x's and y's, so I'm going to put x, and my initial value is 0, so I can put that plus 0 there, but I don't need it. So my equation is y is equal to 6x. Every time my hour increases, the number of cars goes up by 6. One more example. Well, except I put that on the pad so it won't remove it. And the practice is going to have equations and tables and graphs just like this. They're all mixed together. Okay, the function relating the cost, no, I want this one. The function relating the cost in dollars of entering a carnival, C of T, to how many tickets you buy, T, is shown by the following graph. Okay, I love graphs because I know that this is my x-axis, and it actually has an x right there. And this says total cost, and it says f of x, so I know this is my y-axis. So, putting together, remember this is going to be a number, this is going to be a description. My dependent variable is going to be total cost. My independent variable is going to be number of tickets bought. Remember, always this is y's over x's. So, total cost, we don't know where the carnival is. We don't know if they're spending euros or if they're spending yen or rupees or whatever they're spending it in. But since it doesn't say specifically, I'm going to go ahead and assume it's in dollars. So I'm going to put a dollar sign there to say that's my unit for cost. Okay, and the number of tickets bought is going to be what I have for x. It says right there it's x. So number of tickets. Okay, now let's go ahead and see if we can find the slope. We've got a graph. Well, look, I've got an initial value there, but let's go ahead and find a slope triangle. Or we could take 2 points, either one of those. Let's change color so we can see the slope triangle a little better. Okay, I've got a good grid point on the y-intercept. I always do. And if I go up there, it looks like I've got a decent grid point here and a decent grid point here. So I could use any one of those. And rise over run says that I am going up 1 and I'm going over 2. Now remember, this is rise over run. This is going to be y over x. That's what rise over run means. So y's over x, I've got 1 over 2. This time I don't have a 1 on the bottom, so we're going to have an adventure and see what happens. So I've got a unit rate. Well, I haven't done it yet. Let's go ahead and figure it out. So I've got, let's see, $1 per 2 tickets. That doesn't sound really great. But I said I could convert this into decimals. So what is 1/2 of a decimal? Okay, so at one point this says 2 tickets cost $1, but that's not going to be my unit rate. But I'm going to write it down here so you can see what it means. Because that's not a unit rate. Actually, I didn't write that correctly. That dollar sign is still in front. So what does it cost per ticket? That's the unit rate. That's what I want to know. What is the per ticket cost? Well, 1/2 is the same as 0.5. So if 2 tickets cost $1, then I'm going to say that this is 50 cents per ticket. Sorry, I wish my handwriting was better. It's better this time than it was last time. And that is my actual unit rate, because it says it's 1 ticket, and that's what I want to know on a unit rate. All right, my initial value is over here, and my initial value is a y-intercept. Let's erase the green so you can see it. And go back up here. Okay, my y-intercept is 0, 3, and I have to describe the initial value with units. This is a y. What are the y units? They're costs. So this says that my initial value is $3, because that's a cost in dollars. So what does that mean? It means that in order to get into this carnival, I had to pay $3 to get in. After I get in, then I can buy tickets. So $3 is my entry fee, or my flat rate, or my fixed cost. It's my initial value, just to get into the carnival, nothing else. All right, so my equation, I've got, this is going to be my B. I'm trying to make this not confusing. This is B because it's the initial value, and I wanted that to be in red. It's not changing. There we go. Okay, that's B. It's my initial value. Here's my unit rate, which is 50 cents. That is M. So my equation is going to be, I don't want it there, I want it right here. Y is equal to 0.50x plus 3. If I go into this carnival, I'm going to pay $3, and then I'm going to spend 50 cents per ticket. And if I had the number of tickets, I could substitute the number of tickets in, and it would tell me what my total cost is. Want to try that out? Let's go ahead and say that I bought 6 tickets. So 6 tickets, those are X's. Right there, it says that this is X. Those are tickets. So I substitute 6 tickets in, and that's going to tell me my total cost. There's my 6 tickets, plus $3. And if I buy 6 tickets, that is going to be $3, I believe. So my cost at the carnival would be $6. Does that make sense? I hope so. All right, that is the end of this lesson. Go on to the practice, and all the practice problems are laid out like this. Have a good day.